All right, guys, welcome back. Um, we are continuing along with this decimal object. A lot of new stuff's been added. We're going to kind of go over a couple of things that have been added here. Cover a lot of different topics. Um, the first thing that we want to talk about probably is let's talk about these get functions. So I don't know if last time I had these in place, um, but you know how like when you have something like r equal 2, 3, 4, you you can get the r or the length of the array by doing something like r dot length, right? And there are other properties like this. This is the most common one, um, but the notable feature is that it doesn't have the parentheses behind it. So um, that works similar to the dot val here. But what about things that dynamically change? You have, I guess, two options. One is that you set this equal to a function. Um, which presumably would rerun it each time. The other option is that you use something like a get function. Um, and so what that ends up happening, so we've got our decimal. If I instantiate a new object, let's take this one because this one's a bit longer. So we're not on multiplication yet. Console.log a length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the correct answer. And that's because what I've specified as length is just returning the length. Right, this is a string, and it's not doing anything special. If I wanted to not refer to it as the string property, I could just loop through and count the characters, which I'm pretty sure the string get does anyway. I've got two other ones. This returns the length of the number minus the decimal point in the sign, and this returns the length of the string after the decimal. So you can see decimal length 7, and that tracks because these are 3, last one was 10, therefore, etc. And then if I do, what was the other one, num length? That should be 8. Yeah, cool. So the other thing that looks new is I've got all of these static properties. We can ignore these. I have static and I have, or static methods rather. I could have static properties. I don't have static properties. I only have static methods. And I have these other methods that look more ordinary. What's the difference? Well, a static method is something that does not get inherited by new instances. So if I do b equals new decimal, this object b does not inherit static methods. So I can't call these static equality, addition, subtraction. I can call these functions still. And let's just go ahead and crack this open. Last time I had just had an addition property or an addition method. Now I have an add method and I have a static addition method. All this does is run the addition function. I could repeat the code in this, but I figure it's just easier to call it. And the static method actually has the code inside of it. And you'll see this actually looks a bit different. It's more commented out than last time. And what that allows us to do, we'll take the is equal, because I think, so we've got is equal and equality. Equality, and let's say console.log a is equal b. Let's have this equal. Control C, B. So this one should return true. This one should return false. And that's what we get. So if I try to do something like this, though, I should get an error. Yeah, it's not a function. So it's not that I input something wrong I didn't put enough parameters in. I could try putting in another parameter that shouldn't work. Still not a function. The issue here is that equality isn't being inherited by the new instance. Only is equal gets inherited. So that can actually be important for something like us, where what we've got going on now is the regular methods, or I get the ordinary methods, except for is equal. These methods, the add, subtract, multiply, and divide, what they're doing is rewriting this .val and updating it each time. You don't have to have your classes or your methods do that. You can just have them return the answer, the result, and not modify the property. I've set it up that way. Alongside that, though, I have this static method that you can call on the decimal object, which doesn't modify any properties. It can't access because it's not a new instance of something. So when I call it like this, shorten these down. Just for sake of ease, because otherwise we're going to be getting a lot of decimal places. Actually, let's make these the same. Yeah, so, I haven't console.log the second one. Let's multiply. Yeah, and even console log a. Val. See, that modifies the actual value of the A object. You don't have to set it up that way. If you didn't want to set it up that way, what would we do different? Well, all I would do is I would take out this .val equals and return, or this part, and I would just say return decimal.addition, and it would be as simple as that. But if you want to do something like that, just use the static property and not modify. It's as simple as that. We've got multiplication working. We almost have division working too. Let's see what we're doing here. We're going to go into our static. We're going to let neg equal false. And that's going to become a little bit more clear in a sec. You saw in the last video that I had different things that I would do to establish some uniformity. I was allowing taking in decimal objects, strings, and numbers, but I needed them all to become strings at the end. And because I was basically writing the same code in each of them, what I did was added this static method, which handles all of that for me, so I don't have to rewrite it each time. So if it's an instance of decimal, num equals num.val. If it's not a string, it converts it to a string. Then it checks to make sure that it's a float. And then it takes out all of the ending zeros. And then it returns it. So when I'm saying it's equal to it, it's going to return a property, or it's going to return a string, and we're going to set it equal to that. So next thing we're doing is checking to see if the leading sign is negative. If it is, we're going to take it off and just set negative to the opposite of itself. We're going to do that for both. So if both are negative, this is still going to be false. But if one is negative, it's going to get set to true. And that's going to be relevant later on. Because we're going to be taking out, basically what we're going to try to do is set these up as arrays to loop over. And to do that, you can't really have the decimals and the negative signs. The decimals you could work around a little bit easier. The negative signs, it'd be a bit more annoying because at the end, I guess you could just throw in a break statement instead. But they're you can deal with them. It's just kind of annoying to have to worry about something like that. So we're going to take them out. And then here we're just checking to see if anything is zero. This used to be different, so we can actually change that. A fun little fact about JavaScript: if you have an if statement and all you're doing is one line, you don't have to put them in brackets. Kind of like how with arrow functions in callbacks, how you don't need braces. You can just put it right behind, no braces. Save space, etc., etc. If you're getting paid by lines of code, though, go ahead and throw those braces in. And then, what are we doing here? I think we already do this actually up in the cleanse. I'll have to take a look at that and see. Maybe that's just a remnant of me trying to consolidate. That's what it looks like. Yeah, so that must have been something that when I was rewriting stuff, I didn't notice that it was there. What are we doing here, though? We are getting the length of the digits after the decimal place. Why is that important? Well, when you multiply two numbers together that are floats, you might notice that you can end up with more decimals than you started with. We ended up with 3 this time. Actually, you usually end up with 4 in this case, because 2 and 2, you add them together, but the last one is 0, so it got dropped. And we can see that if I try to do 1.21, it should be 5, and it is. And if I do this again, it should be 7. 1, 2, 3, 4, 5, 6, 7. So we get the length of them, add them together, and we know we can start counting back. Once we have the answer, we can just start counting from the back and then toss in a decimal place where it needs to go. Now that we've got that, we can take out the decimal place. I've already taken out the negative sign up above, and all we're left with is the numbers. So let's take them, let's map them with a parse, and we're going to reverse them. You don't have to reverse them. I've been toying around with not reversing them. It's going to go faster if you avoid reversing them, but I needed to get a proof of concept out first before I toyed with it. Then we're going to initialize an array called res. That's actually what we're going to end up with at the end. We're going to keep on messing around with it to turn it in from an array to a number to a string. But we're going to loop through both of these. This is not the fastest way. You can Google some methods. The Karatsuba method is probably not the fastest, but it's certainly it's certainly the easiest to understand out of the faster ways to multiply. I think the quickest way to multiply numbers is n log n right now, although it's horribly convoluted. This is n squared, so quite slow comparatively. But that n log n method really only picks up speed with more digits than we're working with anyway, so it doesn't matter. I'm presuming anyone who would use this library isn't going to be dealing with more than 20 digits at a time, and if they are, then go use another library anyway. So we're looping through. We're starting here. We're saying, okay, we're saying the product is equal to the second array, which is the multiplier in the first slot, times first the multiplicand or multiplicand in the first slot. If the slot that is the sum of I and j is equal to undefined, or is not equal to undefined, then we're going to take that, whatever it is, and we're going to equal it to product. Else we're going to push the product there. Why are we going to do that? Well, let's pull up Paint to see. If you remember doing your multiplication in grade school, you might be familiar with something like this. So 432 times 67. Now, what you were taught was like, this is 4, carry the 1, 7 times 3 is 21, plus 1, carry the 2. We got to carry the 2 here. It's 28, so that's 30. Then, because we're going to the tens column, we add a 0 here. We keep on going. It's 19, 25. Then we add them up. So we're trying to do this in JavaScript. Unfortunately, that's kind of hard because we got to keep on pointing in two different directions with numbers down here and numbers up here. So what are we doing instead? Well, we know that any time there's at least 5 numbers, we're going to have 5 slots of digits with JavaScript. Well, I think there's at least 4. Yeah, there's at least 4. But if we instead look at this as A, B, C, E, F, we notice that this is going to be the ones digit of F times C. This slot is going to have the carry, and all of them forward are going to have carry, so we can ignore that. But this is going to be the sum of F and B and E and C. So that's why we're using these pointers right here as dictating where they are. Because if we look at these, we treat this as a 0 slot in each of them. This is a 1, this is a 2. Then the 0 and 0 are going to give us the 0th slot of our result. This is the F and the B is going to give us the 1 slot, index 1. But so is E and C. That's also going to give us index 1. F and A is going to give us an index of 2. So is E and B. And that's how we know, in fact, F, A, E, B. F's out now. F's gone through everything. But we still have E. E is index 1 here. A is index 2, index 3. and bringing over the carries each time. So that's what's going on here. Because these middle ones are going to be hit more often because you're going to have the 0 index of one array and the 1 index of the other array combined with the opposite, the 1 index of the first array and the 0th index of the other array. Those are getting added in the same vertical space right here, right? So hopefully that makes enough sense. So we check to see if it's undefined first, and if it is undefined, that means we know this is our first time visiting. We're just going to go ahead and push the product. I think you might be able to just set it if it is undefined, but so be it. Now, what we have at this point is the equivalent of, if we went through here, 532, 67, if we look at it as we did up there, what we're left with at this point in the method is 7 times 2 is 14. 7 times 3 is 21. And 6 times 2 is 12. 7 times 4 is 28. And 6 times 3 is 18. And 6 times 4 is 24. So we need to get the tens digit out of each of them. And so that's what we're doing next. We're initializing carry at 0. And we're saying the current, is equal to res on the whatever we are plus carry, which in this case is 0. It's going to change. But on the first instance right here, we don't, in this ones column, we don't have a carry from a previous column because we're at the first one. Then we say, okay, the temp is going to equal the current divided by 10 rounded down. 14 divided by 10 is 1.4, rounded down is 1. We now have the carry. And in fact, I think we could just set carry to that right there. Yeah, now with the refactor, I can just set, I believe I can just set carry equal right here. Because I'm not using it in the res equals anymore. And then res I equals the current modulo 10. So it's the remainder of this divided by 10, which is 4. So we've got the ones column. That's very handy. And we keep on doing that, and because we're adding in the carry each time after, so next time we go down, carry equals 1 on the next loop around. It hasn't been reset because it gets set here, and it hasn't changed since we did this. And so we've got 1, and in this case, we can drag it up here. That's 4 here, and then 3 here that's going to get carried over for next time. So I don't have my calculator open anymore. But if we do something like this, yeah, we're already on the right path because we know this digit is 4 and this digit is 4. 3 plus 8 is 11 plus 6 is 17. That doesn't look right. Maybe I did something wrong. Well, we can look at that later. But the rest of it does look right. So that is curious. Yeah. Anyway. We now have the current, or we've now taken it out, and set each of them to ones digits. The problem is that we only went as far as the array was. As it turns out, in a method like this, we've got to deal with the fact that 2 has been taken out, and it needs to go somewhere. And if it doesn't, we're going to get a wrong answer. So let's see, how do we do that? If carry does not equal 0, then we are going to push. We're still in reverse, so we're okay. Before we do that, though, in case there's any leading zeros, because when you're feeding in zeros from the top with these negatives, there's a chance that the front end is going to be a 0 because of the 0 right here. So we account for that right here by popping those out. It's not going to matter anyway, frankly, because you're never going to have a carry where the front one is a 0, because otherwise that carry would have gotten added where the 0 was. So these are never going to step on each other. Then we can reverse and join. This is now a string. N is res.length minus deci. Deci, if we recall, actually this is a good time to, if you just right click, it'll go to definition x plus y. That's the length after the decimals. So if we subtract that, and it turns out that if deci ends up being, -1 or something, no, it won't be -1. If it ends up being greater, then we know that if it ends up being less than 0, we know that there was never any decimal place in there to begin with, because both of those were -1 in the beginning. So we're only going to add it in if there was a decimal to begin with. We break it up at that point. We add the decimal. If it's negative, we're adding in our negative sign, and then we can go ahead and return. So you can see, let's just test out. This is going to work with or without decimal points. So go ahead and do what we were doing before. Yeah, the decimal place got added at the end. So we do need to fix that, which I can. That's pretty easy. And I mean, this is going to be a rather ad hoc way, but car at length 1. There you go. Simple as that. There's going to be better methods to do that. Writing cleaner code is going to prevent that issue. I'll take a look at that later. And yeah, that's how multiply works. You can see we're just, as with the other ones, we're calling that. Division's almost ready for you guys. I might have it done next week. I don't know if I showed off the exponent one, but I want to save myself some stuff to talk about in case decimal takes an ungodly amount of time to figure out. I had an older way of doing multiplication, which just involved taking out the decimal places, converting them from a string back into a number without the decimals, right? You were just parsing them as ints, getting the answer, and then just sticking the decimal place back in where it belonged. The problem is That method works fine if you have 8 or less total digits, right? If you have 8 or less total digits, you're going to do just fine working that way, because you only run into floating point errors when they're behind the decimal place. In front of it, as long as you're not getting into big int values, you're going to be totally fine. But you get past 8 decimal places, or 8 total character, or 8 total digits in each. You're going to run into you're multiplying them together. You're going to run into issues with the max safe integer, because that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits long. So, I mean, technically, I think it need to be closer to 9 digits each, or some variation thereof, 8 and 10, 7 and 11, etc., etc. But you would run into trouble with the older method is faster, it just doesn't work for longer strings. But I believe it is faster, because might not be, depending on how fast parseInt is, but I haven't clocked it. But that's what it looks like. It's still up. It's going to get deprecated soon. If you see this video sometime in the future, you can go to the GitHub repo. I should post a link to that. And you can still see it back in the old, like the first few half a dozen commits should be in there. So, but yeah, that's it for now. Later on, I'll talk about what object-defined properties is. It's kind of cool if you want to just add stuff later on. It works a lot like static does, or stuff like that, where you can sort of enumerate and control what different things do. I've got the different properties down here, but we'll talk about those at another time. But anyway, yeah, I hope you guys enjoyed the vid. As always, please drop a like. Let me know if you'd like to see stuff. I am just kind of talking about whatever interests me at this point. And yeah, I'll see you guys later.